Hello there. As it appears, we are no longer able to use Zoom. I'm going to make a brief video on the topic of simultaneous equations and solving them. Now, there are a number of ways to solve simultaneous equations. I'm just going to do a quick overview. The first is graphically. That's where you draw both lines and see where they intersect. The solution becomes the point where those two lines intersect. That, of course, only works for two variables in our current world. If you want to do perhaps three-dimensional, you probably could go further, but I don't know how to do that. So draw two lines. The solution is where they meet. They intersect, rather. Right, we started off doing that with a couple of lines. Now, after that, we did a method called substitution. Substitution is where you get an expression for one variable and then you substitute it into a second equation. We did that in class. So essentially involves substituting one equation into another. And solving. Right, third, and this is actually the focus for today, which I will get to in due course, but today, with shiny, happy signs on it, is elimination. This technique essentially involves adding or subtracting multiples of equations, and that's going to sound a bit strange, and that's why we'll do a few examples of it. Involves adding, subtracting multiples of equations. All right, and because I introduced you to the concept of it earlier, you can also use matrices to solve equations, but that's beyond the level that we're currently looking at, but there are techniques there, so that's beyond year 10. So don't worry about that for now, but since I mentioned it in class, yes, it does exist. All right, so today, as stated, the focus is going to be on elimination. I'm not going to be going too nuts here because I have a somewhat sick baby and she is precariously positioned half in and out of a stroller, a little walker thing at the moment, not a stroller. That would be very dangerous, and I don't know how much longer I can be here before disaster hits. All right. All right, so here we go, using elimination. Now, in the previous examples I did a substitution, you would have noticed I had a very clear numbering system. And, I numbered the equations and used those numbers to explain what I'm doing. That becomes even more important with elimination. So, here's an example. If you have two simultaneous equations, and 3x subtract y equals 10. So here I've got two equations. Now, the idea of adding or subtracting multiples is there some way I can add this left-hand side and add this right-hand side to get rid of a variable? Now, in this case, this actually is an easier example. There is a very clear way where I could add or subtract what's on the left-hand side here to get rid of a variable. In this case, if I simply added the left-hand side here together, if I add that expression and that expression, what happens is I'll lose the y. I'll get rid of one variable, right? So we want to remove one variable. That dictates our approach. So in this case, I can see if I add this left-hand side here, I'm going to get rid of y. So what I explain is I go, I'm going to do 1 plus 2. I'm going to add those equations together. When I add the left-hand side here, I'll have x plus 3x. I'll be left with only 4x on this side. If I add the right-hand side, what will I be left with? 16. The y's are gone. Positive y, take away a y, it's gone. I'm left with 4x equals 16. That's great, we can solve that. Divide both sides by 4, we get x is 4. Now remember with these simultaneous equations that you need to get solutions for both variables. So we need y. So we substitute x is 4 into any of those. Pick the equation that looks easier. You will get the same result no matter which one you substitute in with. I'm just going to pick the easier looking one. So 1 looks easier. So if I put x is 4 into equation 1, I get 4 plus y equals 6. Subtract 4 from both sides, we get y equals 2. Therefore, our solution is 4, 2. X is 4, y is 2. I think that pen can go in the bin. Right. So, also remember that if I substitute those values back in here, it should all work. 4 plus 2 is 6. 3 times 4 is 12, take away 2 will indeed give me 10. So that solution is indeed correct. That's the first elimination example. I'm going to do another 2 of them. They do get a bit trickier, but the approach is the same. You're adding or subtracting multiples of the equations to get rid of a variable. Remember, we want it down to one variable to solve, okay? So next set, I'm again going to put up two equations and we're going to work out how to add or subtract to get the solution. This is the process of elimination. So this time the equations are y subtract 3x equals 1 and 2y plus 5x equals 13. All right, now to start with, there's not the same number of x's or y's, so it's not completely obvious right now how I'm going to add them together or subtract them to get rid of a variable. So, but there's 2y here. If I made that 2y, then I'd have 2y in both of them and we can do something. So let's do that. The first thing I'm going to do is define equation 3. Equation 3 is going to be 2 times equation 1. So everything in equation 1 is going to be doubled, and I get this expression. From here, if I do one of these equations, subtract the other, I'll be able to eliminate y. I mean, that's why it's called elimination. We're using this process to eliminate, to get rid of a variable, right? I'm going to eliminate the y's here. And I'm going to do that by either that one take away that one, or that one take away that one. And I'm debating which one to do. I'm going to do that one take away that one, because I think there'll be less negatives involved. So if I do equation 2, subtract equation 3, 2y take away 2y, you'll have no y left, which is what we wanted. 5x take away negative 6x will leave me with 11x. 13 take away 2 will leave me with 11. That looks pretty nice, doesn't it? Divide both sides by 11, x is 1. As always, we need both variables, so I'm going to substitute x equals 1 into equation 1. So y subtract 3 times 1 equals 1. So y subtract 3 is 1. Add 3 to both sides, we get y is 4. Therefore, our solution is 1, 4. Again, we should be able to put the numbers back in here and it should all work out. 4 subtract 3 is 1. 8 plus 5. Yep, 8 plus 5 is 13. So far, so good. I think the baby might be stuck. I'll be back in a moment. Okay, now the third example is going to be the hardest example. This is one where, well, in the first example, we could just add or subtract between the two of them and eliminate a variable. In the second one, we needed to We needed to change one of the equations before we could eliminate a variable. This third one, I believe, is going to be a case where we need to change both equations before we can eliminate a variable. So let's go for it. We've got 3x plus 2y equals 6 and 5x plus 3y equals 11. Now, neither of them have the same number of x's and y's, so this is going to be a pain. Start off with our labelling. This, if you wanted to be technical, we could actually start talking about lowest common multiple here. So, what do I want to target? The lowest common multiple there would be 15. I could change all the equations so that they've got 15x. Or, what's the lowest common multiple of 2 and 3? 6y. I could change all the equations so that they have 6y. I'm going to go for the 6y because that to me seems a little bit less work. So to get 6y in the top equation, I'd have to multiply it by 3. So if I multiply everything there by 3, I'll get 9x plus 6y equals 18. The bottom line there, to get 6y in there, I'd have to multiply everything by 2. So I'll get 10x plus 6y equals 22. Now I can subtract one from the other and eliminate the y variable because we've got the same number of y's. So we're going to do that. What's going to be easier? Definitely easier to go this one, take away this one, I think. I'm going to do equation 4, subtract equation 3, which will leave me with just 1x. 10x take away 9x is just 1x. 6y take away 6y cancels. That's exactly what we want. We didn't want any y's in it. Then 22 take away 18 is 4. Nice. We've already got the value for x. So then we need to then sub our x equals 4 into one of the equations. I'll do equation 1. It doesn't matter which equation I do. I just pick the easier one. So I then get 3 times 4. Oi, what are you doing? Plus 2y equals 6. So 12 plus 2y equals 6. Subtract 12 from both sides, you'll get 2y equals negative 6. Divide both sides by 2, you'll get y is negative 3. Therefore, our solution is 4, negative 3. Now again, you could check that by putting the values back in it. That would be 12. Yep, 12 take 6 is 6. It works in the first equation. 20 take away 9 is 11. That's correct as well. So I can confirm that our solution works. Look, that's the process of elimination. Again, to recap, elimination means you add or subtract multiples of the equation. Keep the left-hand side and right-hand side separate. Add or subtract multiples of equations. To eliminate, which means get rid of a variable. It's different to substitution. Substitution we did the other day where you got an expression for a variable, y equals something or x equals something, and then you substituted that into the other equation. So we've now looked at the two algebraic methods, substitution and elimination. There are situations where one works better than the other. You'll look at them, and after a while, with a good amount of practice, you'll feel more comfortable in picking out whether substitution or elimination feels better for a particular question. But that's it for now. I hope that helps you, and have a wonderful day. Now say bye. Bye, baby.